Hi everyone, Russell Jude here. I head up a company called Edge Designations, where we offer prep services for the CFA, FRM, KIA, and FTP programs. For more information, do pop down to our website, www.edgedesignations.com, or one word. The purpose of this particular video, which is number 4 in our series of how to use your calculator, is to show you how to use your BA2 Plus or your BA2 Plus professional calculators, both of which are covered in this particular video. Keep in mind that the Texas calculator is very commonly used for CFA, FRM, and KIA designations, and that's obviously why we've chosen to cover the Texas as the calculator of choice for these particular designations. This is the 4th video in our series of how to use your calculator. The first video dealt with the basic setup surrounding the Texas calculator. Video number 2 was time value of money. Video number 3 moved on from time value of money to handle cash flows, RRR, and net present value. This 4th video now talks about interest rates. Okay, not necessarily interest rates as we know them with respect to bond calculations. We'll handle that in a later video. This really talks about interest rates in terms of effective rates, nominal rates or stated rates. And again, we're going to talk about the differences between discrete versus continuous calculations and rates as well. Okay, and based on that, we now move on a little bit and we continue here. Okay, on to the next slide, which is the very introduction to interest rate, which is effective annual interest rates. Okay, often called EAR, effective annual interest rates. And remember, and obviously what we like to do in these videos as well is not just to talk about the calculator function, but to talk about the general concept that we are dealing with as well. Over here, we are dealing with effective rates as opposed to things like what we call nominal stroke stated interest rates. Okay, now when a person goes into a bank and asks for an interest rate, they want to put money down on a deposit, and they say to the bank, we'd like to put some money down, $1,000 with the bank for a certain period. What the bank in most instances, or some instances may or may not, they'll quote you what we call a stated rate, or the annual rate, or the nominal rate. Okay, and that's the rate, the general rate. When I talk about the general rate, that's the singular rate. What happens often if there are more compounding periods in the particular investment, more than one, that's called compounding. And then we've got what we call interest upon interest. That's called compound interest. And then that rate that we see, that initial rate, the nominal rate or the stated rate, is not the correct rate, because in fact the rate will be a little bit higher. Why? Because we are earning interest upon interest, and that is called the effective annual rate, or the EAR, okay, often referred to in most of the CFA KIA textbooks, FRM as well, as EAR, effective annual rate. On your calculator, you may often see it as EFF, just the effective interest rate. Now, obviously that EFF, that effective annual rate, is a very powerful rate in terms of its compounding capabilities, and obviously that's the rate that we really want to know a little bit more about, more so than the nominal stroke stated rate. Now, we can calculate that effective annual rate nice and manually should we so choose, and I've given you the formula here. EAR, the effective annual rate, is equal to 1 plus the periodic rate, and that's a new rate that I haven't introduced yet. We've spoken so far about which rates. Stated rate, the stated rate is the same as the nominal rate. That's the annual rate given to you by the bank. Let's say, for example, the bank may say to you, okay, that the stated rate on your investment or on your loan is 12% per annum. That's the stated rate for the year, the nominal rate. The periodic rate, if they say to you, and by the way, you've got to make payments on your loan, or we will make payments to you on the investment on a monthly basis. In other words, so now the interest rate is divided by 12 because the payments are made across 12 different periods. They are made monthly. That 12%, which is the nominal stated rate, the period rate is 1% because you take the total annual rate, 12%, how many periods? Well, it's monthly, so we can divide by 12, giving you a periodic rate of 1% per period or per month. With that periodic rate, we go 1 plus that periodic rate to the power of m, in other words, how many periods in the year, and don't forget to minus 1 on the back end. That will give me my effective rate. So just remember, this is a little bit more of a lecture on interest rates, I suppose, but remember there's always going to be 3 rates that you need to be quite familiar with. You've got your stated or your nominal rate, same thing. That's the annual rate, that's the 12% I spoke of earlier. You've got a periodic rate, that's the rate per period. So you'll take your nominal rate, divide by the number of periods. In my example, there were 12 periods, it was monthly. Your periodic rate became 1%. Then you've also got your effective rate. Your effective rate says, well, my actual annual rate on the loan is not 12% because I am compounding monthly. It's going to be a little bit higher than the 12% as a result of the compounding impact, and that's called the effective rate or the EAR. Let us go and do this EAR because nobody wants to do this. And remember, depending on which designation you're at, okay, I'll just talk about the 2. CFA, you've got 90 seconds per multiple choice question, and at a high level, you've got 72 seconds a question, okay, multiple choice question. There are no times to write out these long formulas. We've got to become very proficient and effective on our calculators. Let's move on to that one, and we'll do this then by way of example. Okay, assuming that the nominal rate is 8%, the question says to you, what is the effective rate? And I'm assuming over here, guys, look what the question has to tell you. How many compounding periods? We're compounding monthly, therefore the number of compounding periods will be 12 for the whole year. Okay, as per usual, let's hop into our calculator, switch the calculator on, and away we go. Okay, so first and foremost, I want to move into a functionality where my effective rate is contained called ICONV, interest conversion. Okay, so we go second function, okay, and I push the 2 button. What do you notice? Let me just clear all that. Okay, let's clear all that out. Okay, second function, ICONV. Okay, and what you notice when you come over here is it takes you to the thing called NOM. NOM is the nominal rate. Now, the nominal rate at this point, I've cleared my screens. You can see, guys, remember, if you don't clear your screens from your previous work, it just sits there. Okay, so I've cleared my screens. My nominal rate now says it is 0. So again, let's just show you that again, guys. How do we get there? You go second function. Okay, second function. Button 2, that is ICONV. ICONV is interest conversion. Okay, nominal rate. Now we know my nominal rate is 8% for the year. And again, guys, remember, whenever we're working with rates, we just put in as a whole number over there. I don't go 0.08, I go 8. Okay. And you know by now, I'm starting to bore you a little bit, I know. Okay, when I put that 8 in, don't forget to push the enter button. Now it is in. And remember, as you can see from all the previous videos, once it's in, it doesn't leave so easily. Okay, we showed you how to get them out. Don't forget to push second function CE. Second function CE, second function, clear all your work. That'll clear your banks. Okay. At this point in time, what have I got? I've got a nominal rate of 8% input into the calculator. Nominal rate is also, for those that are less familiar, is also called the stated rate on the particular investment or the loan. Okay. We use our arrow keys and we arrow 1 key down. That now says EFF. But at this point in time, I'm not yet ready to work out what the effective rate is. But if I just take us back up one, sorry, looking at that nominal rate of 8%, with monthly compounding, in other words, I compound my rate, okay, or my loan every month, we know very clearly that the effective rate is going to be greater than that 8% nominal rate. We don't know what it is yet, but we know due to compounding, the effective rate, because my compounding is monthly, will produce an effective rate greater than the 8. We don't know what it is yet, but just intuitively, just to remember, that's what we are doing. I've got my nominal of 8% over there. Arrow down EFF, I'm not ready for that one yet. Arrow down a second time. Arrow now tells me CY. Okay, now CY says to me, how many periods do you want to compound? Now, I could put 1, okay, or I could decide I can put 12, whatever you want to put, okay. And of course, in my example, what do we know? We know that we are compounding monthly. There are 12 periods. Put your 12 in there, and of course, don't forget to push the enter button, because once you push the enter button, that is what's then going to take you then further into the calculation. Okay, so once you push enter, as we know by now, I'm starting to sound like a little bit of a broken parrot, I suppose. Okay, when we push that enter button, what happens? That's what takes us into, it pushes into the memory banks. Let's go further a page over there. We have now got the 12 in. Remember, once you've pushed the enter button, it's in the memory banks. You don't have to feel, a lot of people feel a bit nervous to move around on the calculator. Can I push this button now that it's in? You can push them with pleasure. Let us have a look at what happens now when I push my arrow keys up and down. I've got 12 periods. That is the monthly inputting. Go one up, it says EFF. We'll get to that in a second. One up says my nominal rate is 8%, and you can arrow down again, and you can see what you want. There's your current period. CY stands for number of periods. You have got 12 periods in there for the year. Monthly, exactly what we need. What I do now is I arrow up till I get to my EFF button, EFF screen. At this point in time, it's a 0 because I haven't put anything in there yet. I've put my nominal rate in of 8%. I've put my monthly periods, my CY in of 12. I come to EFF, to the screen over there, and I push CPT. CPT stands for compute. It tells me that the effective rate is 8.29%. What does it mean that the effective rate is 8.29%? That means if I've got a nominal or annual rate or stated rate of 12%, and that rate compounds monthly, the effective rate is 8.29 or 8.3%. Everybody comfortable? And just a note on this particular section over here, we see there are 3 buttons over here, 3 screens. We've got, I'll take you to the first one, nominal, EFF, and CY. Now, remember, as soon as you've got any of those, if you've got 2 of the 3, you can calculate the third input over there. So remember, there's always 3 inputs: nominal rate, effective rate, and periods per year. You can play around with those as you need. So for example, if the question gives you the effective rate and you want to calculate the nominal rate, well, you'll go to your effective rate there, put your number in there, put your number of periods down there, arrow up to nominal, and push compute for there, and you can compute the nominal rate that way. So remember, it's quite a powerful functionality, this, because the minute you've got 2 of the variables, you can then calculate the third. Of course, in most exams, you're going to be asked to calculate the effective rate, but there we go. Okay, we move onwards. Okay, and I want to discuss a concept over here, which is called continuously compounded rates of return. Now, again, when we move deeper into the syllabus for CFA, Kaya, and FRM, what we'll notice is there are always 2 kinds of rates. There are discrete rates. Discrete rates is what we handled in the previous question. It's a discrete actual number of rates per period. So for example, in the previous example that we did, we compounded, okay, monthly or 12 periods per year. Those are discrete periods. We know those. There are sometimes that the rates of return are compounded continuously, always, okay, all the time. What number is that? Well, it's more than 12 for sure, because it's all the time, isn't it? Okay, the only way we can calculate continuously compounded rates, not the only way, but one of the ways that we calculate them is we make use of logs and exponents. Now, if I wanted to calculate continuously compounded rate of return on my calculator, well, I've got a formula for that. That's e to the r E is the exponent, R is the nominal rate that I'm given. Don't forget to minus 1 on the back end. So in this particular example over here, if again, consider a nominal rate of return of 8% per annum. In other words, it's only compounded one time per year. What if it was compounded all the time or continuously compounded? What would the rate of return be? Well, there's your 8%. Don't forget to push the E button, minus 1. And what do you notice? I get a rate of return of 8.32. What do you notice, by the way? This is continue, and I've kept up the same number, that 8%. If I go back over here, let's go back to my calculator over here. And remember my effective rate over there. What was my effective rate with monthly compounding? In other words, compounding, okay, 12 times a year. Remember, I got an effective rate from a nominal rate of 8.29, compounding 12 times a year. And if I continue, if I compound continuously, I get 8.32. You can see that's slightly higher, isn't it? Why is it higher? Why is 8.32 going to be higher than 8.29? Well, 8.29 I compounded monthly, 12 times a year. And the word I use is discretely. When I compound continuously, all the time, okay, I get a slightly higher interest rate, effective annual rate. What I want to do now, interestingly, I just want to show you how to do this calculation on your calculators. A lot of guys don't come right with this. And if you look over here, well, you say, well, hold on a second. It's not that hard. Look at that. It's not that hard, is it? It's just R, E. Your effective rate is equal to E to the R minus 1. Shouldn't be that hard. You'd be surprised how many issues this causes candidates. Okay, let's get ourselves going and just make sure we can do this calculation on our calculators. So again, I'm going to clear my screens over here, get everything off. I don't want anything on here. Go over there and let's clean up anything that's in there. It seems to be cleared out over there. Okay, now when I'm calculating this formula here, 8%, I go 0.08. Now you notice something different over here. I don't put a whole 8. Okay, even though it's 8%, and up until now, every function, time value of money, interest conversion, I use whole numbers. I would put a whole 8 in here. Here I'm just using the normal calculator functionality, so I've got to put in 0.08. Okay, everybody comfortable with that? Move down to the next page, okay, and I go second function, okay, and I push the lin button. Second function, lin. Okay, and I get 1.0832, which is my number over there. Don't forget to minus the 1 on the back end, and I get to a rate of 8.328. Remember that 8.328 is exactly what I calculated previously. You may say, well, hold on, what are you doing over here? What I'm really showing you is how to do this just step by step on a calculator. So let's just do that one more time again. A lot of people make the mistake. They try and push E. So they go second function, E, and then push the 0.08. Okay, doesn't get to the right answer. So step 1, first and foremost, put in your rate, 0.08. Good. Then you go second function, okay, lin. Okay, the second function lin button is in fact the exponent button. Don't forget to minus 1, and I get to 0.083. That is, in fact, 8.3%. If you wanted to get to a percent from that, you can just times that then by 100, and there is your 8.328% continuously compounded interest rate. Okay, so really just that last little bit was just to show you a bit of manual calculator work, but to show you how to do it then on the calculator. Okay. What I want to show, I'm going to carry on now with continuously compounded rates of return, because you may say to me, hold on a second, hold on. You told us that the continuously compounded rates of return 8%. There's your formula, and we have to do it with a formula, and that's how we get to our answer over there. And you showed us how to do it on the calculator. Let's just do it again, quick. 0.08, okay, second function, e to the x, minus 1, my word, I can't remember all of the stuff, times 100 to get to a percent, 8.33% or 8.328, whatever it happens to be. Is there a way to do, because we've showed you the very first part of this video was what, guys? To show you how to do effective compounded rates of return that were compounded discretely, monthly, okay, quarterly. We did monthly, but you could do it quarterly, whatever it happens to be. Can you do this continuously compounded calculation using the interest conversion function? Let's show you how to do that. Okay, a little bit of a trick, but a nice one to know notwithstanding. We're going to fool the calculator. Let's have a look over here. Okay, clear my screen over there. And remember again, what am I working with? 8% nominal rate. But I want that 8%, and I want to say, what is the continuously compounded rate of return? In other words, not monthly, but what if I compound that every single second? Okay, that's called continuous compounding. Let's go. So first and foremost, we're going to go second function, rconv. Just be, if you want to give yourself a little bit of certainty, just page down and make sure there's nothing in your calculators over there. At the moment, I've got CY of 12. Doesn't matter. Let's go back up there to nom. I'm quite happy that we are clear enough. Okay. So first and foremost, what I do over here, guys, okay, let's go here and to my nominal. Everybody comfortable? And again, because I'm back in my calculator functions of rconv, cash flow, anything like that, net present value, I can put whole numbers again for my interest rates. Remember, the only time that you don't put whole numbers like an 8 for your interest rate is when I'm working on the actual calculator, actual calculations, etc. Yes, then I've got to use 0.08 as a percent. Okay, I've got my nominal over there of 8, and again, don't forget to push the enter button. There we go, push enter. It's now in the interest conversion bank, memory bank as 8%. We arrow down 1, we arrow down 2, because I don't want effective rates just yet. Remember, what am I trying to do over here, guys? I am trying to convert my 12%, sorry, my 8% nominal rate to a continuously compounded rate and forever rate. When I come over here, this is the little trick, guys. When you come over here to CY, number of periods, now the Texas, not being overly smart, doesn't recognize that forever is forever. How do we fool the calculator? Number of periods. If I put in 500 periods over here, the calculator thinks that what? Okay, that's forever. Okay, so just put 500 periods. Normally for monthly, we would put 12. For discrete, we've got to put the exact number quarterly or monthly for 12. But for continuously compounded, what can I put? 500. Now the calculator thinks, whoa, this is for sure forever. Okay, don't forget to push the enter button, and the 500 is in. We arrow upwards to get to EFF. Don't forget to push the compute button, and you can see I get very close again to my 8.33. Why do we get very close to that, guys? Of course we do. Okay, because the calculator reads 500, which is my period that I put over there, as a continuous, as a forever kind of a rate. It's a lovely little trick to use if you don't want to use. There are two ways to get to continuously compounded rates. The first way we showed you got to use the formula, the exponent. This is another way to get to it by using the second function 2, or the rconv, interest conversion function. Guys, this then brings us to a conclusion of the fourth video relating to interest rates, showing you the differences between discrete rates and continuous rates, exponents, logarithms, and how we calculate those. We will continue onwards then with the fifth video coming up.